Alright, let's look at the homework 14.3, problem number 8. Let's find these second partial derivatives. Alright, so let's take the partial with respect to x first. So it's going to be partial of z with respect to x. Right? So this is going to be, right, derivative of arctangent is 1 over, so you have a 1 over 1 plus x squared, but instead we have this expression, so we have to take that whole thing and then square it. So we have x plus y over 1 minus xy squared, right? Then multiply by, so chain rule, derivative of exactly the same thing. So quotient rule, squared the bottom, so 1 minus xy squared, right? Then take the derivative of the top. I'm just doing the quotient rule. So partial of x with respect to x is 1, and the partial of y with respect to x is 0, so that's it. So times the denominator, which is 1 minus xy, minus numerator. So numerator is x plus y, multiplied by the derivative of the denominator. So partial of 1 with respect to x is 0, and the partial of a negative xy with respect to x is negative y. So we get that, right? Then we need to simplify this a little bit. So this is going to be equal to, alright, so I'm going to distribute this denominator here to both terms, here and here, right? So the the denominator is going to be 1 minus xy quantity squared plus, right? So you can see that you have 1 minus xy squared, and you have the same thing. So they basically cancel out. So this guy cancels with that guy. So we get just a numerator, which is x plus y squared, right? And on top, we just have to clean up. So it's going to be a 1 minus x squared, sorry, not x squared, xy, and that will take care of that guy. Then we just need to distribute negative y to both terms to get, so you have a negative y times negative x, so it's going to be positive xy, and negative y times negative y, so plus y squared, right? So we can cancel xy here and xy there, right? Then we can simplify it, so this is going to be equal to, right? So I'm going to just multiply the denominator out and see if we can do anything. So you have a 1 plus y squared, right? If you multiply it out, you're going to get 1 minus 2xy plus x squared times y squared. So that's that. And the quantity x plus y squared would be x squared plus 2xy plus y squared. Right, so we have that. Right, then we can cancel. You can see that negative 2xy and a positive 2xy. Alright, then you can actually factor out the denominator here. So maybe I should, so here, if you want to factor this out, so right here, All right, so this guy. All right, if you group these two terms, x squared, y squared, and x squared, so I can do this. We can write it as, let's see right here. All right, so since x squared is in common, so I'm gonna pull out the x squared. Then you have, let's see, 1 plus y squared. Right, 1 from here, y squared from there, right? Then you have a 1 plus y squared sitting there, so you have a 1 plus y squared sitting there, right? So you can see that 1 plus y squared is in common, so I'll pull that out. Then we have a 1 from here, and a plus x squared from there, right? So therefore, we're going to get this. You have 1 plus y squared over quantity 1 plus y squared times 1 plus x squared, right? Then we can cancel 1 plus x squared on top, the same thing on the bottom. So you end up getting simply 1 over 1 plus x squared. All right, now we have to take another derivative. So we have partial of z, second partial, with respect to x, right? So you can use quotient rule if you want. Let's do a quotient rule here. Right? If you square the denominator, so 1 plus x squared squared. Right, derivative of the top is 0, so I'm not going to write that. 0 times the bottom minus top is 1 times the partial of 1 plus x squared with respect to x would be 2x. So we have a 2x. So you would get simply negative 2x over quantity 1 plus x squared squared. All right, so let's type it in. All right, so let's what we got was negative 2x over quantity 1 plus x squared quantity squared. All right, so let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, so let's look at the mixed partial. All right, so mixed partial, we want to find the partial x first, then partial y. So you have z x partial with respect to x, and the partial with respect to y. All right, so let's find that. All right, so this one is actually quite easy because a partial with respect to x is only written in terms of x. So this is constant if you're taking the partial with respect to y. So partial of constant with respect to y would be just 0. All right, so let's type it in. We have 0 there, so we'll check the answer. Submit for testing. All right, we got the mixed partial correctly, and also z of I'll go ahead and do this one. All right, so we want to find a partial with respect to y. All right, so let's do that. Then you can see that here x and y are symmetric. If you switch x and y and xy, it's exactly the same thing. So you just have to write down the symmetric answer. You can go through exactly the same steps, and we get the 1 over 1 plus y x squared. So you just have to switch x and y. So you're going to get the 1 over, right, 1 plus y squared, right? So we get that. Then if you take the mixed partial, z, then with respect to y, with respect to x, since this is written completely in y, there's no x. If you take the partial with respect to x, you're going to get 0, right? So partial with respect to y, x is going to be 0, right? So go ahead and check the answer. All right, looks like we got this one correctly as well. All right, so the last one. So we want to find the partial of y, a second partial, both with respect to y. All right, so we have, all right, so again, we're going to do the same thing, and we can just use the quotient rule. And 1 plus y squared squared, and it's going to be negative, so partial 1 is 0 times the denominator minus top times the partial with the denominator would be 2y, right? So this is going to negative 2y over 1 plus y squared squared. So again, we could have just a switch x and y there. So let's type it in. We're going to get negative 2y over quantity 1 plus y squared squared. All right, so submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.